All right, so this is my video for lesson 6.4, but before I actually get to the content of 6.4, I want to review what we talked about in 6.1 and 6.3 to make sure that you understand the difference between the two, okay? So lesson 6.1 was solving quadratic equations, and we talked about different scenarios. Quadratic equations, okay? You could be working with a quadratic relation in standard form, factored form, or vertex form, okay? Now, let's do a nice little throwback to grade 9. Woohoo! In grade 9, when we were given an equation, I don't know. There we go. When we were given an equation, solving that equation meant isolating the variable, okay? And so here's a linear equation. I would bring this to the other side. So I would have 3x is equal to 3 minus 27, 3x is equal to minus 24, and x is equal to minus 8, okay? Now, the problem with that strategy when we're talking about a quadratic equation, particularly in standard form, so let's look at this guy. What if I gave you this? Okay, we can't use that same strategy from grade 10 because I can't isolate the variable. I can't get x by itself because I have an x squared here and I have an x there. Okay, so what we thought would work from grade 9 doesn't serve us if you're trying to solve a quadratic equation from standard form. Okay, so then we spent an entire unit 4, and all kinds of strategies, learning how to take a quadratic relation from standard form to factored form. We're going to use those same skills. The only difference now is it's not a quadratic relation. It's not this. It's a quadratic equation because of this. So if you are given a quadratic equation in standard form, you ensure that one side is equal to 0 and you try to factor it. This is actually right from your note. This is example 2a from the note. So I'll just kind of write that down, okay? And if you look at example 2a, I was able to factor this. Every term was divisible by 3. The nice thing about a quadratic equation is you don't have to include that 3 in your solution. You can put it out in front if you need to, if it makes you feel better. But the fact that that is equal to 0, I can just divide both sides of this equation by 3, and then that gets wiped right out, okay? So I can common factor this guy, and then I'm left with an easy trinomial. What adds to 9 and multiplies to 20? 4 and 5, okay? So in question 2a from the note, I was given a quadratic equation in standard form. Back in 6.1, the only strategy that we had when given a quadratic equation in standard form was to take it to factored form by factoring, okay? In this case, I common factored and I factored an easy trinomial. From here, I can set the factors equal to 0 and solve. These are the solutions, these are the roots, these are the values of the independent variable that satisfy the equation. If I plug -4 into here, left side will equal right side. You can pause this video and try it yourself. Also, if I plug -5 into here, and here, of course, left side will equal right side, okay? The problem is, what do we do if we can't factor from standard form, okay? And that's where today's lesson comes in. The trick in this unit is making sure that you understand which strategy to use and when to use it. Back in lesson 6.1, so I'm going to use this opportunity to do a little recap, we also talked about what we would do if the quadratic relation was in vertex form, okay? And that would look something like this. So if vertex form looks like that, and we're given an equation that looks like this, 34 is equal to -2 x plus 1 squared, I don't know, minus 3, okay? Yes, we could absolutely use our skills to expand and simplify, take this to standard form, and then factor it. But that is just a colossal waste of time. This is the one instance where we can actually use some skills from grade 9 and isolate the variable. And that's when we move all these guys to the other side. And we've used this skill in previous units. So in 6.1, our options were, if the equation was given to us in factored form, awesome. Set the factors equal to 0, solve, have a nice day. If the equation was given to us in standard form, we had to take it to factored form. If the equation was given to us in vertex form, we could isolate the variable. Today's lesson focuses on equations in standard form that cannot be factored. And so I'm going to jump right to example 3 from the note, because all of the other examples in that particular lesson, they can be factored. So I want to take you to an ugly one that can't be factored and show you what this looks like, and then we can go back and do some additional examples. So number 3 is a word problem, so that's kind of nice. I know those are everybody's favorite. It says a rectangle is 5 centimeters longer than it is wide. And immediately I need a diagram because I'm already confused a little. Rectangle, 5 centimeters longer than it is wide. So this is how wide it is. I'm not really sure, but I know that it is 5 centimeters longer. And a lot of times kids will say, Miss, why didn't you call that length? Because I don't want to have 2 variables floating around. I don't want to have to worry about W and L. So if I can just stick to W, it makes my life a lot easier. Okay, the diagonal of the rectangle is 18. Alrighty. Determine the dimensions of the rectangle. So I know that if I can solve for W, ultimately I'll be able to solve for the length as well. I really like this word problem just because it has a nice little Pythagorean theorem throwback. So we're going to need an equation to work with, if anything, because the title of this note is the quadratic formula, which is used to solve quadratic equations. So I know that Pythagorean theorem states if I square the sides of a right triangle and add them together, I get the length of the hypotenuse squared. And we're going to use that right here, right now, to solve this particular word problem. So it's almost like we kind of want to pretend this isn't here. Whoop. All right, which would mean that this side, oh, I love when my markers do that. This side squared plus, now be careful, this side squared is equal to the hypotenuse squared, okay? Now, this looks a little fishy, so we're definitely going to have to do some work before we can actually use this equation. Copy this guy. Now over here, when I square a binomial, I square the first term and that goes first. I square the last term and that goes last. Then I multiply these guys together. W times 5 is 5W, and I double it for the middle. So that's a nice little throwback to a skill from Unit 3. Now I'm going to square 18, which is 324, okay? And I'm getting a lot closer. I just have to adjust this formula, meaning make one side equal to 0 and collect like terms. So I have a W squared and a W squared, which means I have 2W squared, plus 10W, and now I've got to bring this guy to the other side, right? So 25 minus 324 is minus 299. And that equals 0. Okay, so that's kind of what the word problems do. The word problems make these questions more challenging because we have to come up with the equation ourselves. They're not just handed to us. So they gave us a scenario, right? We had a rectangular field where the length was longer than the width. The diagonal was 18. I used my knowledge of the Pythagorean theorem to come up with this equation. And then I simplified and collected like terms. And now I am here. So if my goal is to get the dimensions of that field, I have to solve for the width. I have to solve this quadratic equation. And then if I add 5 to the width, that will give me the length. So what skills do we have to solve a quadratic equation? Well, if it was in vertex form, I would isolate the variable. I can't do that here because I have a W squared and a W. So that's not going to work. Since it's in standard form, I can try to factor it. Okay, which would mean I'm looking for 2 numbers that add to 10 and multiply to, oh dear, something big and ugly, minus 598, I believe. Okay, here's a clue, guys. On a test or quiz, you would know that this guy can't be factored because I would say round your answer to the nearest 2 decimal places. So if I'm telling you that you're going to be rounding, for sure you won't be factoring because you're going to be getting nasty decimals. So this can only be solved using the quadratic formula. Okay, so we're 10 minutes in and I'm going to finally show you what that looks like, even though it's the title of the note. If this guy is in standard form, that means this is my A value, this is my B value, and this is my C value. And you want to be super, super careful with the signs. A is equal to positive 2, B is equal to positive 10, and C is equal to negative 299. All right. This is the quadratic formula. X equals minus B plus or minus the square root of B squared minus 4AC all over 2A. And believe it or not, guys, I still have that memorized from when I was in grade 10 in 1996. Off to the side here, I'm just going to write these down so you can see them. They're on my other board, but you can't. We said that the value of A was 2, the value of B was 10, and the value of C was negative 299. All right, so I'm very methodical when I use the quadratic formula. The first thing I always do is just write it out. Okay, you're going to be using the quadratic formula regardless of whether you take 3M, 3U, or 3C. So you just want to make sure that you learn it well now. Write it out. It doesn't take long, and it's going to improve your chances of memorizing that formula. In the second step, I like to get myself organized with some brackets. Whoa, Nelly, sorry. Equals minus B plus or minus the square root of B squared minus 4AC all over 2A. Okay, and then I just fill those brackets in, and again, this minimizes my chance of error. So this is B is 10, and B is 10 here, okay? You know I like things color-coded. Oh my goodness, you guys, I'm losing it. A is 2, so 2 here, because that's 2 and that's 2. And C only appears once in the quadratic formula. So negative 299, I'm going to need more room. Negative 299. Okay, so in the first step, I write down the quadratic formula. In the second step, I replace all of the variables with brackets and fill them in. This is the way I'm going to mark it, so pay attention because this is what I want to see. In the third step, I want to see 3 numbers, which means you're going to simplify this a little bit. So right here, that's negative 10. Okay, a lot of times kids will ask, Miss, if this was negative and then there's a negative there, do those guys cancel each other out? Yes, they do. Plus or minus the square root of, okay, this you can do all on your calculator in one full swoop. 10 squared minus 4 times 2 times negative 299 equals. And I want you guys to try that on your own because if you're not getting this, we have to figure out why. Your entire solution will be incorrect if you can't get that value. Okay, so again, third step, I want 3 numbers. I want to see this guy, I want to see what ends up being inside the square root, and I want to see what is in the denominator. Okay, now, in the next step, when I'm going to mark your tests and quizzes, I want to see you break this down. So from here, we get 2 distinct solutions. We get minus 10 plus whatever this works out to be. In this case, it's 49.92 over 4. And we get minus 10 minus 49.92 all over 4, okay? And this is very familiar because we ran into examples similar to this back in Unit 5, okay? So we're going to get 2 answers here, okay? Over here, we get 9.98. And again, please don't forget, I'm just going to put a little star here, to make sure you press equals before you divide by 4. Same thing with here. And so you guys should be trying this. Oh my gosh, this phone thing. You guys should be trying this along at home to make sure that you can calculate this correctly. And those are our 2 answers. Those are the roots. Those are the values of x, which in this case is w, that satisfies this equation that we came up with, what felt like 10 minutes ago. Okay, now let's talk about these 2 answers, okay? W, we were solving for W, but I mean in the quadratic formula we call it X, it's fine, represents this value right here, okay? The width of this rectangle. So it makes no sense. It's impossible for me to get a negative measure, and I want you to tell me that on an assessment. I want to see that you understand that that value is impossible. So this, in fact, is the width of that rectangle, okay? So we're going to take that answer back to our initial diagram. If the width is 9.98, is this meters? No, centimeters, okay? And we know that the length is 5 centimeters longer than that, and we add 5 to that, the length would be 4.98 centimeters, okay? Okay, the next example I want to show you, I apologize for kind of working backwards, but is 2b. 2b, it's not presented to us in any form. It's not in factored form, it's not in standard form, it's not in vertex form. So we definitely have to clean this guy up a little bit. Let's get rid of the brackets. So I have x squared plus 3x. And we know that to solve a quadratic equation, it has to equal 0. So we're going to bring these guys to the other side. That's minus 5 plus x squared. And now we'll collect like terms. So we have x squared, and x squared is 2x squared plus 3x minus 5 is equal to 0. So this is example 2b. We have a quadratic equation. It's not a relation because it doesn't say y equals. And I'm interested in solving for the value of x that satisfies this equation. Notice not once in the last 14 minutes have I used words like max, min, optimum, greatest, least. This lesson is not about finding the vertex. This lesson is about solving quadratic equations using the quadratic formula. Now, this is in standard form, and I could use the quadratic formula, but I want to show you how if the equation can be factored, that is a quicker, more efficient method. So here, if I was going to try to factor this, I'd be looking for two numbers that add to 3 and multiply to negative 10. And those numbers are negative 2 and positive 5. So I'm going to go ahead and factor this using decomposition. Recopy the first term, that goes first. Recopy the last term, and again, equals 0. I should see that in every single step. And now I'm going to decompose or break apart this middle term into a positive 5x and a negative 2x. Now I apologize. Common factor the first two terms, 2x plus 5. Common factor the next two terms. Oops, sorry, negative x. Woohoo. 2x plus 5. Okay, what do these guys have in common? They have a 2x plus 5 in common. And what do they have left over? What am I doing, guys? I am so sorry. Woohoo! They have an x minus 1 left over. Okay, so clearly the teacher here has to review Unit 4. So I just factored this quadratic equation from standard form using decomposition. Now, from here, I can finish solving this quadratic equation by setting my factors equal to 0 and solving for x. So I've got x is equal to minus 5 over 2 and x is equal to 1. These are the solutions, these are the roots, these are the values of x that satisfy the equation. If I went back up here and I plugged in negative 5 over 2 for that and that and that value of x, left side would equal right side, and you're welcome to try it on your own. Then, if I took this answer of 1 and I substituted 1 into this equation where x is, left side would equal right side. Okay, so this is kind of a nice unit because, as I said in the 6.1 lesson, you can verify your answers before you're done an assessment. Obviously, if it's a homework question, you're going to look at the back of the textbook. All right, let's go back to here. Before I decided to solve this by factoring, okay, I want to show you that even quadratic equations that can be factored can also be solved using the quadratic formula. So let's decipher our A, B, and C value. Oh dear. A, B, and C values. Oh, that's bugging me. Okay, and then plug those into the quadratic formula. A is the coefficient of x squared. B is the coefficient of x. C is this guy floating around by himself. If there was no value here, you would just say that C is 0. Okay, remember, I'm very specific in the way that I want to see the quadratic formula used. So the first thing I want to see when I'm assessing is the quadratic formula written out. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay? In the next step, I want you to replace the variables or the letters with brackets. Okay? Then you're going to fill those brackets in with the a, b, and c. That's why it's kind of nice to have it written down in front of you. So a is 2. There's an a here and here. B is 3. C is -5. Okay. Third step is where I want to see 3 numbers. That's how you're going to remember that one. So I have -3 plus or minus the square root of. Okay. This works out to be 49. Again, you should be trying these along with your calculator. You can pause the video if you need to, because if you're not getting these numbers to match, that's not good. I don't want you to be going into a test or quiz and have questions about how to calculate this. All over 4. Okay, so write the formula down, plug the numbers into the formula. Third step is where you simplify, so all I see is 3 numbers. And from here, we break it down. We have -3 plus 7 over 4. Okay, so that one's nice. It works out to be a nice number. And we have -3 minus 7 over 4. Okay? -3 plus 7 is 4. 4 divided by 4 is 1. That's the exact same answer we got by factoring and setting the factors equal to 0. Over here, -3 and -7 is -10 over 4. I'm running out of room. And that reduces to -5 over 2. I also got that answer previously. So you will get the exact same answer using the quadratic formula as you will by factoring. The only problem is not every relation can be factored. And additionally, okay, if it can be factored, this is just too time consuming. There's too much chance for error. So you will be given an assessment where I give you 3 different equations. Sorry, I'm very visual, so I just wanted to have this in front of you. You will be given an assessment where you're given 3 different quadratic equations. One of them is in standard form, but can't be factored. One of them is in standard form, and it can be brought to factored form, and one is in vertex form. And it will say in the instructions, you must solve each of these 3 equations using 3 different strategies. So if it can't be factored, you always use the quadratic formula. You have no other options. If it can be factored, factor it, right? And if it's in vertex form, which is what we talked about at the beginning of the lesson, so if it looks like this, this would be the example where you would just get x by itself. You would isolate x.